Today we're going to cover covalent bonding and nomenclature, and I'm going to show you how we create covalent molecules, which is through a covalent bond. And I'm going to go over with these three examples how we would also write the formula and name these molecules. So notice now that we use a slightly different term. So we're going to use the term molecules now more than compounds. Covalents are still compounds, but we tend to use the term molecules for them as opposed to compounds. So compounds tends to be referred to ionics, okay, so when you have a metal and a non-metal, as opposed to covalents when you have only non-metal elements. Okay, this is the big difference between ionic and covalent compounds, bonding, nomenclature. Okay, you have to recognize that you have non-metal elements and then they bond very differently, and then the way we name them is very different from ionic compounds. Keep in mind that sometimes covalent is referred to as molecular. Okay, so I feel like in the resource note, they also use the word molecular. Depending on who taught you in grades 9 and 10, when you talked about compounds and bonding, they may have used the term molecular. I don't use that term. I use the term covalent. It's more of a true chemistry term than the term molecular. So just be aware, it means the same thing, and I am going to tend to use this term of covalent. Okay, so it's only non-metal elements, and the difference between covalents and ionics is that covalents will share electrons when they bond. Remember that ionic compounds are formed by electrons being transferred from the metal to the non-metal element. So here you don't have a metal. You only have non-metals. So their electrons are shared together and then they bond. As a result, they form a new chemical compound that has a specific formula and name. So let's go through and show what happens here. So as usual, you need to have a periodic table, and you have to know the number of valence electrons for each of your elements. So carbon is located in group 14, and as a result, he does not have 14 electrons. He has 4 electrons, and we always place these as singles going around and then come back and pair up if we need to. Hydrogen sits in group 1. Group 1 elements have 1 valence electron. So what we do is these 2 electrons, these single electrons, are going to find themselves, and we're going to draw a big circle, not really a circle, big long bubble, to find those electrons, and they would pair up in a little group of 2. So hydrogen only wants 2 electrons. He's quite happy with that. He sits in group 1, or he sits in period 1. Most other elements need 8 electrons to be stable. So hydrogen is good, but carbon is not. Carbon has shared this electron right here, and he now has a total of 5. He needs 3 more. So what we do is, because carbon has these single electrons, we're just going to bring more hydrogens around and bond those electrons together. So we're going to do that there. We're going to do this here. And then again, right here. Then we show little circles indicating that those electrons have paired up. Do not leave it like this. You should be cleaning that up. And for every pair of electrons that we have, we're going to represent those as a bond. Okay, so watch what I do first, right? So we're going to have that pair of electrons right over here, right? Bonded. And so instead of me even showing the pair of electrons like that are bonded, I'm actually going to erase that, and I'm going to put a line in between them. Okay, so every time we draw a line, that represents the sharing of 2 electrons. Okay, so again, right here, you can see there's 2 electrons in this bubble, And then I represent that by one single line, okay? Now, what is the chemical formula for a covalent molecule like this? You take typically the atom in the middle, okay, not always, but usually, and you write it down, and then you count up the number of atoms. So we have carbon first, hydrogen second. There's only one carbon atom, so we don't write a 1 in, we never do, but we have 4 hydrogens, so we write a formula like that. Okay, so similar to ionics, where we just count up all of our elements or all of our atoms. Now, how do we name this? Well, this is different because we're not doing a transfer of electrons like in an ionic bond. We don't have ions like we do in an ionic bond. So when we name this, it's kind of similar, but a little bit different too. So we state the full name of the first element, and then we add IDE to the second element. So in this case, we're going to call this carbon, and then we're going to call the hydrogen hydride. But the difference is we don't just call this carbon hydride. In covalent molecules, we have to use prefixes to indicate how many atoms we have. So I only have one carbon. You'd think that I would call it monocarbon, because mono is the prefix for one. But we actually leave off the mono from the first element. On the second element, I have 4 hydrogens, and the prefix for 4 is tetra. So we say that we have a tetrahydride. Okay, so carbon tetrahydride is the name of this chemical formula when it is a covalent molecule. So you have to know your prefixes. We're going to have a chart for you so that you know them all. But you should know those and have learned them in grade 10 science. Okay, let's keep going. Here's hydrogen and oxygen. So hydrogen sits in group 1. He has 1 valence electron. Oxygen sits in group 16. Okay, so he's in group 16. He does not have 16 electrons. Remember, we lose the 1. He has only 6 valence electrons. And again, very, very important that you place those electrons around as singles, and then you pair up after you place those first 4 singles. Hopefully you can see what's going to happen here. So any single electrons are going to try to find themselves and pair up with each other. So hydrogen and that single electron on oxygen will bond. Oxygen still has this electron left over, so we're just going to bring in another hydrogen. Okay, so you always bring in the opposite element, and we're going to bond them together. Now over here, I have these sets of electrons, okay, that are already paired. Don't touch them, okay? Do not touch. Leave them alone. And they are stable, they are paired, they don't need to be removed or separated, okay? You can only pair up single electrons. So let's clean this up, okay, because this is looking messy. And remember what we're going to do. Any electrons that we have bonded, we're going to rewrite with a line. So here's oxygen with his pairs of electrons. It's very important that you put those in, okay? They have to stay there, but we only replace the bonded electrons with lines, okay? Now, you should all recognize this molecule. This is water, but water is the common name. And what is the chemical name? Well, this is a covalent molecule. We are going to actually start with the hydrogens in this case. And when I come up with my formula, I have 2 hydrogens and I have 1 oxygen. So remember with covalence, I have to indicate the fact that I have 2 hydrogens. So we use the prefix for 2, which is di. So I'm going to start writing this here. So we're going to say this is dihydrogen, right? We use the full name of the first element. And then on my second element, I have oxygen. I need to add the IDE suffix, and I need to add the prefix. Now, when there's only one element and it's the second element, you do use the prefix for 1. Okay, so we're going to call this dihydrogen, And then mono is the prefix for 1. And then because this is a mono oxide, we combine the O's and we just call it monoxide. Okay, so the chemical name for water is dihydrogen monoxide. Let's show some bonding for nitrogen and chlorine. So again, we go to the periodic table. Nitrogen is sitting in group 15. Chlorine sits in group 17. They do not have 15 and 17 valence electrons, but they have 5 and 7. So let's take nitrogen first. Oops. And show 5 valence electrons. 1, 2, 3, 4, and then 5. Here is chlorine. Chlorine has 7. 1, 2, 3, 4, 5, 6, and 7. Any single electrons are going to find themselves and pair up. Don't touch any electrons that are already bonded. So that tells me that on nitrogen, see how I have 2 singles left on nitrogen? I need 2 more chlorines to come on in and be able to bond to that nitrogen right there. And then here's my other chlorine. And again, those singles will find themselves and pair up. We're going to clean this up so it looks a little bit nicer and it's just easier to see. That's very messy when I look at that. And there are those 2 electrons on the top of nitrogen. Very important that you place them there. And then we're going to take the bonded electrons to chlorine and we're going to replace them with a line. And then put in all the other electrons that are around. What is the chemical formula here? Well, again, we usually start with the element in the middle, and there's only 1 nitrogen. And then I've got chlorines, and I have 3 of them. So there's my chemical formula. And then how do I name it? Well, again, with covalence, full name of the first element. But if it's only 1, we do not write in mono. Now, if you do, that's fine. I'm not going to take off marks for that. But we just don't tend to. So we're going to call this nitrogen. And then for chlorine, it's the second element. I have to use that IDE suffix. And I have 3 chlorines. So I write in trichloride. Okay, so covalent bonding and nomenclature is actually easier than ionic. Okay, it's a little bit simpler, and you don't have to worry about the crisscross rule or ion charges or anything like that with covalence. It's a lot easier. You just use the prefixes to indicate the numbers